I heard this when I was a young engineer. I go to my boss and I talk about a problem I have, and he'd say, "Don't bring me problems," and all together now, bring me solutions, right? And those solutions that we're going to talk about today in Moldflow, we're going to talk about filling, packing, cooling, and warpage problems and solutions, and some of the specialty processes that we can cover as well. And our motto here at CAE is predict, identify, and solve. This was our first problem, filling a thin wall in this application here. The membrane had to be less than a quarter millimeter in thickness. And so as you can see, if you were to just straight injection mold that, you'd get an air trap situation here and a possible non-fill, because that air might not be able to get out anywhere and would compress and superheat and possibly burn that area, or just cause a short shut altogether. So one of the solutions we came up with on this one was a compression solution. So, we were able to essentially pull the core back that was forming this at different distances to see how it was going to affect the filling pattern. You can see when we pulled it back to 0.6 millimeters as our start position, still getting a little bit of a backfilling condition here. And then ultimately pulling it back 1.2 millimeters for our start position was the best solution. And you'll see that here in a second. You'll see this core start to move. So we fill through that area and then compress the material out of the way to get our 0.2 millimeters membrane. So that's one way to do it. And the total time was 0.6 seconds to both fill and compress that. Cycle time, obviously, we want to be able to try and predict the cycle time that we're getting in all of our molds, whether it's for quoting purposes or what have you. We want to make sure that we're able to understand what we're up against when it comes to a cycle time. So in this same example, without the baffles, after 83 seconds, we're able to get the average part temperature down to 148 degrees in that area there. When we added the baffles to get to that same temperature, we were able to knock 16 seconds off of that cycle to do so. And then by adding the Mold Max slide there to get down to that same temperature, now we're down to 40 seconds. So that's huge, to a molder. 43 seconds knocked off of that cycle just by changing the mold design as we did. That's a deal breaker right there. If you quote that project wrong and you expected to get, something like 40 seconds maybe, or 67 seconds even, and then you get surprise at the press, 83 seconds, what's that going to do to your profit margin? So it's good to understand these problems before they happen, for sure. So I hope you get the sense here, for those of you maybe more new to Moldflow, that it's a problem solver. It's a game changer. It allows you to make a difference really in how things happen with your molding operation. It's like taking an MRI of your mold. It's been the gold standard since 1978, so there's a long track record of problems that Moldflow has been able to help solve. It's become part of our injection molding vernacular. Everybody's got to do a Moldflow, right? And I would argue there's been no greater impact on the efficiency of injection molding than Moldflow. That's gone from reactive to proactive analysis. Many companies are writing it into their standards now. And I would argue that everyone should have some level of Moldflow in-house. What is a Moldflow? It could be one of two things. We've got the Moldflow Advisor product and the Moldflow Insight product. Moldflow Advisor is intended for part designers and mold designers. It's more of a directional analysis, and it came in response to users wanting more entry-level type of analysis. Whereas Moldflow Insight is the flagship product. It's recommended for engineering analysts. When should I use each of these products? To answer questions like, can this or can I do this? Answers with yes or no. Use this up front to determine the capability of or moldability of a particular product. Whereas Moldflow Insight answers more of the why. Why did this happen? Why did I get warpage? Why does my part not cool as quickly as I thought it would? What happens when I do this? What happens when I add a Moldflow or a Mold Max insert to this particular part? What happens when I change the wall thickness? What happens to the warpage in that case? Can I get out of a buckling situation? So it's specific answers to specific questions, and we use it for definitive optimization and problem solving. And we get definitive warpage values. That's an important thing too.